Hello guys, welcome back to Maths on African Motives. Still working on O-level mathematics, that is working on the construction and LOCI concept. We are going to be revising the June 2008 question paper that has got the bearing part on our construction. So if we are to check, definitely we are supposed to use our compasses for all the constructions and the ruler. So given this first part, let us check what we have. We have got three schools that are P, Q, and R, and these three schools are given such that the bearing of Q from P is being 0.45 degrees. Remember, if you are given three digits like this, it means we are referring to the three-figure bearing in this case. So this is a three-figure bearing. And that of R from P is given as 300 degrees. We're also given the bearing of R from P and the distance P and R, which is 18 kilometers. Q is due east of R. So that is the information that you're given. So what you need in this case, the first thing part is to sketch this information that you are given, depending with the bearings that you're given from each point. So let us start with the first information that you're given. We are given that the bearing of Q from P, this is the first statement that we have, from the point P is 45 degrees. So remember, we are supposed to work with the point from. Where are we coming from? From the point P. So that is, we are going to have our point P in this case. So this is just a sketch. So let us have our North Pole at point P. So from this North Pole that we have at point P, that is where we are going to refer the first bearing. So we are given that this first bearing, Q from P, is 45 degrees. That is 0.45 degrees. So remember, the three-figure bearing is taken in the clockwise direction. So meaning to say, from this point that we have in the clockwise direction, from the North Pole going in the clockwise direction, that is how you take your bearing. So 45 degrees, we just expect to be in between 0 and 90. Remember, this is 90 degrees. So we expect this to be somewhere here in between. So that is what you're going to have, which is 45 degrees. So on the diagram, you just indicate the angle. Angle here is 45 degrees. Yes, on the part that you're given, it's given as 0.45 degrees. But when you are now representing on the diagram, there's no need for you to write 0.45. All right. So that is going to the point Q. So Q is somewhere here. We do not know exactly where the point Q is, but we just know it's along this line. All right. Let us move on to the second statement. From the same point P and that of R from P, the same point P is 300 degrees. From the same point P, we are going to move an angle of 300 degrees, meaning to say, according to this, we have got 0, 90, 180, 270, back to 360. So we expect 300 moving. Remember, our direction is the clockwise. So we are going to expect to have the 300 in this quadrant. That is more than 270, but less than 360. This is 270 here. This is 360. So we are going to expect somewhere here. So that is our angle of 300 degrees from the North Pole. Take note, these angles are taken from the north in a clockwise direction. So that is gonna be 300 degrees. And on this case, if we are to take note, also we are expecting R in this case to be along this line. That is what we just expect. We expect R to be along this line. We do not know exactly where the R is. But if we continue with this statement here, we are also given this part that the distance between P and R is 18 kilometers. The distance between P and R is 18 kilometers. So meaning to say between these 2 points from P going, remember R is somewhere this side. We are given the distance of 18 kilometers that we are going to write now in this case, depending with the scale, using a scale of 1 centimeter to represent 2 kilometers in this case, meaning to say wherever we are given 1 centimeter, we are seeing 2 kilometers. And here we have got 18 kilometers. So we are going to divide this 18 because we are given this as a ratio. 1 centimeter is corresponding with 2 kilometers in this case. What about the 18 kilometers that we are given on this part? It is going to correspond with what? So you're asking yourself, 18 kilometers corresponds with what in centimeters? So simply, we are going to divide this, which is going to give us 9 centimeters. So we know that there is a difference in between this point from P to a point that we are referring to as R. There is a difference there of 9 centimeters according to the centimeters, but this is just a sketch. So we now know that if R is at this point, we can have a North Pole at that point R, knowing the distance that we are given, which is 18 kilometers, but in centimeters, that would be 9 centimeters. Also, we are given that Q is due east of R in this case. This Q is due east of R. What does it mean? It means from the point R here, this is the North Pole. If we check at R, we are having a North Pole. If we move in the east line, remember here we are having the east and we are having the west. If we move straight in the east, that is due east. If we move straight in the east, like from this point straight in the east, that is due east of a given point. That is where this line is going to meet with the line from P, where we are now referring this as our Q. So that is how we are going to have our Q. So meaning to say the due east concept is still at 90 degrees because this is taken from our North Pole. Remember, that's 90, 90, 90, 90. So if it is due east, it is straight along the 90-degree angle. So that is what you're going to have on our sketch. So with this sketch, we are going to construct the given diagram now that is taking from what? From this sketch that you're having. As we can see, we've got a closed triangle at the end. So that means we can be able to sketch to construct our diagram in this case. All right, so let us have our instruments for construction, which is in this case, we just need a ruler and a compass in this case. All right, so these are the instruments that we are going to need so that we can be able to construct this whole triangle. So the question that you are supposed to ask yourself is, before you start to construct, since all these constructions, as we saw that from this sketch, they are referred from the point P. The point P is the one that is generating all these points that we have. The point R, the point Q, all they are being taken from P, where we are having a North Pole in this case. So how are we going to construct a North Pole? That is the question. So the North Pole is simply taken from constructing 90 degrees. The moment you construct 90 degrees, we have constructed the North Pole. So the concept of constructing 90 degrees is the one that you're going to use. Remember, how to construct 90 degrees, we first need our line. Just this is going to be enough. So from this line, that is where we are going to make our constructions from. I just hope it is going to be clear. Mark a point of your choice, construct 90 degrees. So we are going to mark a point maybe somewhere here. All right, with this point, we are now going to mark 2 points that we are going to have on the line this side and another one this side. All right, so these are the most important points that we are going to work with, this point and this point, to construct our 90 degrees. So open more than half at this point of the line. You're going to open more than half. Construct an arc and another arc down on top. So you're going to have an arc on top and another arc down, but it's not even necessary since there is a reference point there. Without changing the distance, marking from this point, we are going to do the same thing, marking from this point here, an arc on top and another arc down without changing this distance that you are having here. So you're going to have an arc there. All right, so let us try to join so that we construct our North Pole, which is the 90 degrees in this case. All right, so like I said, the moment you are constructing 90 degrees, you have constructed the North Pole. That is the indication of a North Pole in this case. All right, so here we are just going to join. I just hope it's in between exactly the points that we want. So now let's analyze from this sketch that we are having here. Do we want to analyze from the sketch that we are having here? If we are to check from the point P, because we are having our North Pole here, this is our North Pole. From the point P that we are having, there's an angle of 45 degrees taken to Q, where we do not know where the point Q is going to be at. So meaning to say, to have the angle of 45 degrees here means that we are going to bisect the 90 degrees. Remember, to bisect 90, you obtain 45, 45. So we are going to bisect this angle so that we obtain the angle of 45 degrees. All right, so remember, to bisect an angle, we are going to need 2 points. All right, one in this point and the other one on this other end. All right, with these 2 points, without changing the distance, we are going to mark an arc where we expect our 90 degrees to our 45 degrees to be at. So that is, without changing the distance, we expect our 45 degrees to be somewhere here. All right, we do the same thing from this end, where we expect this time these 2 arcs must join at a certain point like this. All right, so as you can see, these 2 arcs are joining. So we are going to have our angle of 45 degrees in this case. All right, so let us see what we are going to have if we are to join from our ruler. All right, so like I said, by joining this, we are constructing the angle of 45 degrees, but we do not know exactly where this where this Q is going to be at. So just try to construct a line which is long enough from this point, all right, to the intersection of the arcs. Just let it be long enough like this. So this is from the point P having an angle of 45 degrees, all right, from the point P, to the Q. So Q is just along this line. So we are going to see this Q later on because we are told that it is due east of R. So we need to construct, or we need to have the point R first. All right, so the question is, how are you going to construct the point? How are you going to construct this angle of 300 so that we obtain this R here, which is 9 centimeters from P? All right, if we check from the concept of angles here, we are going to see that at this point that we have constructed the 300 degrees, this part, we are remaining with an angle inside the shape, inside here, this one, in between from the North Pole. We have got this 300, there's an angle that is remaining here. What is this value of this angle? Angles at a point add up to 360. So 360 minus 300 degrees, this whole angle here, we are going to remain with 60 degrees. The 60 degrees that is inside, we know how to construct this. So we are going to simply construct 60 degrees here. By constructing 60 degrees, we have already constructed this remaining angle of 300, because 300 plus 60 gives us 360 degrees. So that is the technique that you're going to use. So we are going to construct 60 degrees somewhere here. That means if we construct 60 here, the remaining of this angle is going to be 300. All right, so let us construct 60 degrees from this point. So our 60 degrees must be on this side. So we must have our arc on this side. All right, so that is from the point P at the intersection. Remember how to construct 60. You're going to need an arc in this case from these points. Let us choose this one. We are going to need an arc, just a bigger arc like this. All right, this is enough. Then without changing the distance that we are having here, this distance, without changing it at this point, you are going to mark back at this point. All right, so let us do somewhere like this. All right, somewhere here like this. So as we can see, these two arcs, they intersect at this point. Where they intersect, join to this point, meaning to say this angle that you've created is 60 degrees. All right, so that is the concept of having this angle. Now let us try to join this one. All right, I want something like this. All right. So we are going to join our points or the point of intersection. So the angle that you have created here is 60 degrees, this angle that we see. So we are going to join up to this point like this. All right. So meaning to say, if we have constructed 60 degrees, what does it mean from this point? If we have constructed 60 from here, all right, from this point to this point, if this is 60 degrees, what does it mean? It means the rest from this point up to this point, it is going to be 300 because angles at a point should add up to 360, like I said before. So this is the angle that we want, this one. So from this point up to this point, the whole of this angle is 300 degrees. All right. So that is how you were supposed to construct the 300 degrees from the point P. And we are also given the distance there. If we check, we are also given that from P to R, because we do not know where R is, but we can take advantage of this distance to say from P to R, which is from P to R, it's 9 centimeters. So we can measure 9 centimeters on our ruler. So you take your compass, you measure 9 centimeters on the ruler. So in this case, let's say this is my 9 centimeters somewhere here. I'm going to mark with this 9 centimeters from P, all right, on this direction. So I need this 9 centimeters, but on this direction, all right, somewhere there. So somewhere we need, let it be closer to the line. So this is the arc that we are going to have. So we have constructed a point which is 9 centimeters from the point P. So that is our point R. So R is lying at this point. This is where we have our point R at this point. But at R, if we check, there is a north pole. The reason for us to have a north pole is because we are told that the point Q is on the east of R. So it must be along this line to the east, going to the east. So there's a need for us to have the north pole at R. So how are we going to have a north pole? You are not going to just take your ruler at this point, you draw a line like this and you say, this is my north pole. That one is not going to work. So how do we construct the north pole at R? That is the question. All right, you're going to use this idea here. What we know about these north poles, the north poles themselves, they are parallel lines, these ones. They will never meet. North poles will never meet. They are parallel lines. So if they are parallel lines, it means they maintain the same properties as the parallel lines to say that the alternate angles are equal, which is the Z angles, the ones that create a Z. This angle and this angle must be equal. Also, this angle here and this angle must be equal, the ones that where we create a Z. Every concept of parallel lines must work because we are saying they are parallel lines. So in this case here, if we check here, we can take advantage because we know that this is a parallel line with this one. And we have an angle of 60 degrees here. So it must be the same as this one if we are to create a Z like this. So it means the angle here, if it is 60 degrees, this angle also must be 60 degrees so that these two lines automatically, they will be parallel. And if they are parallel, it means this line is a north pole because we are saying north poles, they are parallel. So that is the concept that you're going to have in this case. So meaning to say, we are going to construct an angle of 60 degrees. This angle is 60 here. So we want to create a Z like this so that if we have 60 degrees here, this line is going to be parallel. So our 60 degrees must be on this side. This is where we expect our 60 degrees to be at. All right. So remember the concept of constructing 60. Like I said, we are going to need an arc, all right, from this point. Just mark an arc like this. With this point on the line, we are going to mark without changing the distance on our arc again like this. So meaning to say this angle that we are going to have here is going to be at what? At 60 degrees. All right, so we are going to join these 2 points. All right, so let us try to have these 2 points joined together. By joining these 2 points, we are going to see that the line that we are creating there is actually a north pole from what we are having. All right, did I actually have these points taken properly? All right, we are having something like this. All right, exactly. So this line that we are seeing corresponding to this line that we are having here, they will be parallel because this angle is 60, this angle is 60 degrees. So definitely it means these 2 lines, they will be parallel to each other. All right, so that is the concept that you're going to have, meaning to say this is a north pole. So from the north pole that we are having here, what we want is to have a line going to the east, because we are told due east of R. This is to the east of R. So we are supposed to construct the 90 degrees going to this side, so that, remember the concept, if this is a north pole, east is at 90 degrees. So we are supposed to construct 90 degrees going this side from this point. So the same way that we construct 90 degrees, meaning to say we are going to need 2 points from this point. All right, 2 points. Let us have 1 point here on this side. All right, so we are going to just need an arc here and another arc on this side. All right, this is too close, but it's fine. So we've got an arc on this side and another arc there. So with these 2 arcs, we can open more than half. We are aiming this point here. This is our aim. So we are going to open more than half from there. Just open more than half. All right, this is more than half. Construct an arc on top and another arc down, but there's no need because already we have got a reference point. So these 2, they are enough. All right, I'm gonna construct another arc like this. So as you can see, these 2, they do meet at this point. So where these 2 meet, if we are to join this part, if we are to join, we are going to obtain a north pole. We are going to create a line which is the east, west, and east. But as we are talking that it's due east, so it must be to the east. So this line must be drawn going to the east. All right, so we must draw this line going to the east like this. So that is what we are going to have. So as we can see, as we are drawing this line going to the east, it meets with this line at this point. Where these 2 meet, that is where we are having the point Q. So definitely, or by default, this is going to be our point Q. So that is how you work with the bearing. You do not just draw lines from nowhere and say, this is my north pole from nowhere. Each and every part that you are supposed to construct should be taken from a certain concept, any mathematical concept that you have, not just to draw a line like this. Okay, here just draw a line like this. I say it's my north pole. I draw a line like this. I say it's my east line. No, you have to use the concept to say, okay, if I know that these 2 lines are north poles, so the angles here, they must be equal from the concept of the set angles or the alternate angles. If there is a concept of corresponding angles, let it be from those corresponding angles, depending with the idea of the angles, how they are presented from this side. All right, so that was our first part of the question in this case. All right, so we want to check the other part of the question, which is the item 2. use the diagram to find the actual distance between P and Q. So there we need to measure the distance. So what you're going to simply do was to measure using your ruler, and don't forget the scale that 1 centimeter represents 2 kilometers. All right, so this is a item 2, so you can even write it here, a item 2. So you are going to measure from P to Q on your ruler. So here depends with the value that you're going to obtain. So here I obtained something like 6.7 centimeters, but this is in centimeters. They want the actual distance. So you're supposed to multiply by 2 to get your answer in kilometers, since you are given that 1 centimeter represents 2 kilometers. So like I said, depends. Maybe yours it's 6.8, it's fine. We're going to use that 6.8. Maybe it was 6.9. You use the value that you obtained by measuring. So please measure properly. The value that you obtain is the one that you're going to obtain. So on this one, I was going to obtain 13.4 kilometers. So it's just an approximate value, plus or minus 0.3 in terms of your calculations. All right, measure properly using your ruler, or you take a divider, you measure, then you place on the ruler to get the exact value on the ruler. This is how you work out this type of a question. Then the last part on the construction was to construct the perpendicular. That is the item 3 in this case. To construct the perpendicular from R to P to QP produced. How do you construct the perpendicular from a point to a line? We are saying this point, when we are to draw a line to meet this line, it must meet this line at 90 degrees. That is the perpendicular from a point to a line. So how do we come up? How are we going to come across with that condition to construct the perpendicular from our point? R, it's a point. QP, it's a line. So we need the point R. This is where we have our point R here. All right, this is where we have our point R. And this is our QP. But they are saying QP produced. What does it mean? It means this line can be extended, this line that we see. So that is, we can try to extend, that is to produce a line further from what it is given. So here, I'm going to extend this line so that we can see how it can be like. All right, so that is the PQ produced. Just extend this line. All right, so we are going to extend our line further like this. All right, so that is to produce a line. Just extend that line. All right, so we want to construct a perpendicular from R here to this line that we have extended. It must meet here at 90 degrees. How are we going to do this? All right, I said you are going to construct from this point, that is from the point R in this case. So from point R, you need a distance that you're going to open. This distance, okay, let me try to reduce like this so that we can obtain this side. So from this R here, you need to open a distance that is going to cross this line at 2 positions. It must pass through this line at on 2 positions. The line that we have extended, this arc must cross or must pass the line at 2 positions. So you have to try, like you open like this, you try, okay, is it going to pass? You can see it's not. You extend again until you obtain a condition where this line is going to pass at 2 conditions. Like let me use this one so that we can properly see. If we extend, if we mark an arc like this, all right, that's an arc this side, and we mark it like this, extending from the same. As we can see, we can have an arc this side and an arc that side. That is what I'm trying to say. So this arc that we have constructed, which is marking at this point here and at this point here, we are supposed to go back to these points. We mark an arc back to R, another arc here, another arc, and another arc, then we join. So without changing this distance on your compass. So don't change this distance as it is. We go to the point here, to this point, we mark an arc down this side here, another arc definitely is going to pass through the exact point that you started with, which is P, all right, which is R there. All right, you do the same thing from this side. All right, let's just hope. Let me take it up a little bit here. So we're going to do the same thing without changing our distance. At this point, we must have this arc going back to the R, okay? Then it must intersect with this one. All right, so if we take it this side a little bit, these two are going to intersect. So that is the idea that we are going to use. So what we are trying to say is that if we adjoin from the point R here to the intersection of this line is going to be perpendicular. It is going to be at 90 degrees. So let us extend and see. Let's extend and join our points and see if we are going to have this part properly. All right, so that's somewhere like this, okay, which is fine. So I think somewhere there is fine. So you are going to join from this point to the point of intersection like this. The line that we have just drawn now, this line that we see here, when it meets this line, it meets this line at 90 degrees. That is, it's perpendicular from R to PQ produced this line. That is how you construct the perpendicular from a given point to a given line. You need first to mark an arc which is going to affect the 2 points. In this case, we are going to need something like this from a point to a line. So you must open a distance which affects 2 points on a line. This arc must affect 2 points on that line. Once this arc is the line is affected at 2 points, without changing the distance, construct an arc back and to test. So this is just to test if it is passing through that same point again. You mark another arc down. From this point, you mark an arc, then you mark an arc. By joining these arcs, the line that you have constructed from this point here to this line, it's at 90 degrees. So that is the concept that you are supposed to work with on your constructions. All right, so make sure that you just revise basically these steps. These are the most important steps that you need to work with or that you need to understand. All right, remember this was 9 centimeters. If you still remember PR. Okay, let's check the other part of the question. Now they are saying calculate the area of the triangular region PQR, giving your answer in square kilometers. All right, we need to calculate the area of the triangular region PQR, which is this one, this region PQR. This is what we have here. All right, I extended too much here. This is the region that we have. So how are we going to calculate the area giving our answer in square kilometers? It means we are supposed to use these units in kilometers. Remember, this is the shape that we are working, this triangle. We are working with this triangle, and we want to calculate the area of this triangle. What are we having? Remember, we calculated PQ, this one. We got this line, the length of this PQ in kilometers. You use the value that you obtained. We are also given RP, this one. So what type of a triangle are we having? We are given 2 sides and an angle in between both days. Remember here we said inside this angle is 60 degrees and this angle is 45 degrees. So if we combine these angles inside the triangle, it's 60 plus 45, which is going to give us 105 degrees. So it means inside here we've got 105 degrees. So we are going to use the area concept to say area is equivalent to, remember area, when you are given a non-right angle triangle, it is going to be half AB, a sine of theta. So that means our area is going to be half of these units in kilometers so that we obtain our answer in square kilometers. So that means we are going to have half of R to P or PR. So it is going to be half of PR times from P to Q, which is the part of the triangle that is forming this angle here in between. So that's half of PR times PQ sine of theta, where our theta is this angle of 45 plus 60 inside the triangle, which is 1, or we said it's going to be 105 degrees, or you can use 75 from 180. Remember, sine is not affected. Sine obtuse and sine acute are the same. All right, so area is going to be half of PR in kilometers. This is the 9 centimeters that we got previously from 18 kilometers, or just multiply by 2 to convert to kilometers. So this is 18 kilometers times PQ. Our PQ here in kilometers, we calculated PQ. You use the value that you obtained. So here I obtained 13,4. I don't know as for you, the value that you obtained, you use that one that you obtained times the sine of theta, where theta is this angle that we obtained, where we said it's 105 degrees. All right, so this is going to give us the area of this triangular field. So according to my values, according to these values that I'm having, I'm going to obtain 116,49 square kilometers. So let us know the values that you're also obtaining, so that we can tell if truly your values are in the required region, to say in the approximated values that are given, plus or minus, are we in that same region. So that is going to help us. So this is how we attempt questions on bearing. What we need is to understand the concept of the parallel lines of north, the construction of north poles, the parallel lines concept, and also understanding due east. What does the part due east or due west mean? If we are given our north pole, like we've got north, south, east, and west. Due south, it means straight to the south. That is due south. Due west, straight to the west. If it is due north, that is straight going in the north line. Due east, we are extending in the east line. But knowing that these angles, they are separated 90, 90, 90, 90 from each point or from each other. So that is the idea that you also ought to understand also when you are working out your questions. All right, so more questions to come as we are revising towards our exams. All we need to do is to work now with more question papers. Let's revise more question papers in preparation of our exams. That can actually help us a lot. But for now, that's it. Till we meet again.